you've got your work cut out for you. Let's talk about your solution and about all other solutions. How does your solution, let's start there, help to prevent or solve the problem with what is already out there?
I would say that our solution is not the end all be all. It's simply a tool in the toolbox to help deal with the problem. Because you cannot simply replace, you can't solve a problem by developing. It's a complicated situation, because what this is really about is about behavior and responsibility and doing things in a sustainable way. So unfortunately, this is very cultural, and humanity has a really bad habit of just throwing stuff away. So what we have endeavored to do is create a solution that would maybe put a dent in the problem, make it a little bit easier to create a sustainable environment in space by being able to repair, replace, upgrade, refuel, so we don't have to send as much mass into orbit. So with all that being said, we build these robots to try and address that problem.
Mm-hmm. Bring us up to speed with what I've read about. Well, I've read a little bit. I'll let you explain. Who's Fred? What are Fred's capabilities? What is an Orbot?
So an orbital robot is effectively a small satellite or a satellite that can go out and autonomously go and deal with a problem. Now, right out of the gate, no, they're not going to be fully autonomous. However, that is the goal. That is Rogue's goal, is to develop spacecraft that are fully autonomous, that can go and deal with space debris. It can go and attach something to increase the drag on a spacecraft that is decrepit and deorbit it faster. Go and inspect an object in space so that we can find out what's going on and what's wrong. There's a series of Orbots that we have. The first one is called Barry. He's a very small little robot that is used to test and demonstrate some technology. Then you have Laura, who's an inspection and observation satellite spacecraft. Then you have Charlie. Charlie is a robotic enabled spacecraft, a little bit larger, about 150, 200 kilograms. And then Fred, the one that you asked about, is this really, it's a pretty sizable spacecraft at 325 kilograms. It's got 4 robot arms. It kind of looks like a Hornet whenever it's fully deployed. It's pretty cool looking, and it's got an array of highly sophisticated sensors that we use to do a lot of detection and understand the environment that's around it.
Can you tell me a little bit more about Fred? So what is the objective for Fred once you have Fred in orbit?
So Fred will be able to transport the smaller Orbots around the Earth and move them to locations where they might be needed to do inspections and observations or post them around something. Fred can also grab a hold of something. It can attach to something and move it. It can attach other things to another object. It has the ability to detumble an object in space, because in space you have these things up there, and they're not static. They're not just sitting there. They, with the Earth's influence and gravity and solar winds, they actually start spinning and moving in the various axes. Well, with that being said, you have to be able to detumble that stuff, and that's why we are exploring the omni-magnet technology with University of Utah. So with that being said, Fred's purpose is basically the tow truck, the forklift, the mobile repair shop, because you can even change out tools at the end of those robot arms, depending upon the circumstances that you find yourself in.
So give me a sense of your timeline. When can we expect the, I guess, some footage on this first time, maybe?
Yeah, so we're putting up our first couple of spacecraft in the next few months. Hopefully by February, we'll have those first couple of smaller spacecraft up. May, we've got another, we have a Lara going up, and we're trying to, we don't know if it's going to work yet or not, or excuse me, the timeline is going to work yet. But we're aggressively going after Fred, which is the very large one, by the end of 23, early 24, trying to put that in space. It's a very aggressive timeline, but hey, it'll be a fun goal to see if we can pull it off.
This is really fascinating. So I also read a little bit about collaboration with ESO, which is the AI-enabled sensory observation platform. What exactly is that?
So in order to actually understand what's going on, you have to aggregate all of the sensors and all of the sensor inputs that that the spacecraft is using. Everything from radar to LiDAR to range finding to all the cameras, all of it has to get aggregated, put together in order to clearly form a contextual picture of what's around it, what's moving, what's not moving, where it is in relation to the target. It's a highly complex problem that has to be solved. And on-orbit servicing requires the aggregation of that. And that's what ASOP does. It aggregates everything in order to formulate decisions to conduct a safe operation in space, because we don't always have real-time access to the spacecraft. So if there's something that starts going wrong, the system, the Orbot needs to be able to say, hang on a minute, this is wrong, I need to back off. And then it can just disengage from that object.
Step back to your reference to omnimagnets. Can you describe a bit more on the concept and how the technology works?
It's really fascinating stuff. It's some real Star Trek stuff. It really is. You may not know this, but every metal is affected by magnetic waves, some more than others. So like iron, for example, that's really on the end of the spectrum where there's a strong influence. Aluminum and copper, not so much, but there's still an effect. Omnimagnets project out magnetic fields, and the eddy currents that are generated through those magnetic fields pass through the metal within an object and can actually influence it over time. And so one of the dirty secrets of space debris and space debris removal that nobody wants to talk about except for Rogue is, how do you detumble an object without breaking it? Okay. So if I fly up to a spacecraft, or I fly up to an object in space and it's rotating and spinning around, well, I have to bring my Orbot up to it, and then I got to try and maneuver and match all the spin and everything so I could safely approach and grab a hold of it. Well, that is very expensive from a fuel standpoint, and it's almost impossible to do. I can shoot it with a harpoon, and then the mass of this object and the speed at which it's moving will just grab my Orbot, twirl it around, and then we have disaster. I can shoot it with a net. Well, if I shoot it with a net, I still have the same problem, except now I've probably broken off a few extra pieces and I'm getting drug along with it. Magnetic eddy currents and omnimagnets solve that problem because we don't have to touch the object. We can stand off, we can project the magnetic fields, and over time, we can slow the spin in those 6 axes so that we can safely approach, grab a hold of it, attach drag lines and attach drag streams to it, and then allow it to decay naturally into the upper atmosphere and let it burn up. That is a safe, sustainable, non-debris creating way of solving a problem. And Rogue happens to be in partnership with University of Utah to do that. It's already demonstrated in the lab. We've already, it does work. It's real. It's not science fiction. It's science fact. But it's a beautiful, brilliant combination of physics and AI, machine learning, and robotics. It's really an elegant solution.